Good afternoon, everyone. Hope you guys have had good 2 days. Thanks for hanging out with us at the Arm session. My name is Bhumik Patel. I'm with Arm, part of the software ecosystem team. And with us, we have Julio, one of our staff engineers who's worked on the NGINX performance on the AWS EC2 A1 instance that we'll talk about in this session. And then we have Nilay Thakur from AWS, from the EC2 team. I guess important things first. We have a $50 AWS credit vouchers. We'll hand it out to you guys after the session. Stick around. Thanks to Nilay and AWS team. All right, so let's get started. I think if you were at the keynote, you got some glance of what Arm is all about. So I want to do a quick overview of, Arm is a very unique business model. It's a IP licensing, global leader in IP licensing technologies. So it's basically, we sell CPU IP to our semiconductor partners, and our revenues are based on those license sales and royalty sales after the chips are sold. And you can see some of the stats here. Sold 140 billion plus Arm-based chips out there. One of the interesting stats I like to share is it took Arm first 22 years of Arm's existence to sell up to 50 billion chips, and then took next 4 years to sell the next 50, right? So the growth we are seeing is pretty exponential. There are a lot of reasons behind it, and we'll talk a little bit about it. But that's why we are investing in, further investing in the roadmap for server class IP, things that you can drive infrastructure from cloud to edge. So it's a very unique business model. It's very ecosystem friendly business model because we do innovations that our partners can leverage and build their platforms and solutions around. So we are kind of an R&D, literally no pun intended, arm for a lot of these partners. So it's very unique in that sense. I think one of the reasons why we see this exponential growth is due to the data explosion we see in IoT. Right? I think we saw some of those stats in the keynotes yesterday. But fundamentally, this model is shifting from downloading content from the internet, now going the other way, all these devices pushing data back to the cloud. And then depending on the data and the latencies and what you're going to do with that data, it'll be processed at different stages, right? Whether it's an IoT gateway or an edge or back in the cloud. But that's why we are seeing this explosion of Arm-based chips. Historically, we are all very strong in the device space, and also in the embedded device and all the IoT, the things within the IoT. But moving forward, we are processing this across the infrastructure. So at a high level, we have this Arm Neoverse brand of IP products, which basically has a full-on roadmap to have scalable, performant, CPU IP architectures, right? And we'll have AWS talk about what they're doing with us as a great example. But what you can expect is you're just not going to see us just in the devices, things of in the Internet of Things, moving around from the edge to the cloud. So that allows us to have a very scalable architecture. So I think and we have a lot of other trends as well in addition to IoT. How general compute is becoming more discrete with a lot of offloads and specialized compute that we can, we are out at the booth happy to talk about it. But today what we want to do is focus on the EC2 A1 instances and then look at the NGINX work. So I'm going to ask Nilay to come up and brief you about what AWS is doing with us.
All right, thanks, Bhumik. How's everybody doing? Great. Hi again, my name is Nilay Thakur. I'm Product Marketing Manager at AWS. Just want to give you an introduction to Amazon's EC2 A1 instances. But before we start, how many of you are currently using AWS? Show of hands. Okay, so about 30% of the audience. How many of you are aware of these A1 instances? Okay, so not a lot. So A1 instances are basically ARM-based Neoverse core instances. And if you guys are, most of you are already familiar with AWS, but based on the recent Gartner Magic Quadrant for Cloud Infrastructure as a Service, AWS was positioned highest in execution and furthest in vision compared to any other cloud vendor. And really the key point here is that AWS has thousands of services, right? Many of them are container services, as advanced as machine learning services. And EC2 is really a fundamental service on which many of these services are built. So EC2 innovation, we actually started with one single instance type in 2007, and that has grown to more than 210 instance types as of mid this year, right? And that's continuing to grow exponentially, right? And this innovation is really driven by our key tenet of innovating on behalf of our customers and giving them the broadest and deepest selection of instance types that best works for their workloads. So as part of that innovation story, AWS announced the AWS Graviton processor last year at reInvent, which is based on 64-bit Arm Neoverse cores. And really, this is groundbreaking in terms that this is actually the first processor that's based on the Arm architecture in any major cloud provider platform. So the instances that are based on the Graviton processor are called Amazon EC2 A1 instances. And really using these instances, you can, if you have native Arm architecture-based workloads, you can run those workloads natively in the cloud. Or if you have any workloads that are well-suited, for example, scale-out applications that are well-suited and platform-independent, you can easily run them on these A1 instances and get up to 45% cost savings. And obviously, we are going to be talking about running NGINX Plus on these A1 instances and getting up to 40% cost savings for NGINX. SmugMug, how many of you guys know SmugMug? Okay, so almost everybody. It's a big photo sharing, photo processing service. It's been around since 2002, and they are 100% AWS for their platform since 2012. They are using A1 instances for their photo tier. So they have their web tier, their photo tier, and the photo processing tier, right, which takes care of all the graphics manipulation. So the photo tier is actually responsible for passing these photographs and all of the elements that they have between the web tier and the photo processing tier. And it's really a great match for A1 instances because of its first platform independent nature, and then second because it's really IO intensive, right? So very, very easy scale out. It was really easy for them to move to A1 instances. And if you're interested in hearing more about this customer story and about other customers, we do have that on our website. So these are just some examples of applications that you can run on A1 instances. Web tiers are typically really well suited. And by the way, we have thousands of customers using A1 instances today and getting those cost savings. Almost all of them have migrated their applications seamlessly from other kinds of EC2 instances to A1 instances. So web tiers, containerized microservices. Again, these containerized microservices make them really platform independent and easy to move over to A1 instances. Caching fleets, again, caching fleets are more IO intensive. Most of the time, the processor is just waiting on the IO operations to complete. So it's a big cost saving for customers who have data stores and caching fleets to move onto A1 instances. And then IoT, gaming, and ARM-specific workloads, right? So these are workloads where, how many of you have native ARM workloads? Any of you building applications for the ARM architecture? Okay. So if you're building applications for the ARM architecture until today, you did not have an easily available on-demand method of building and testing your applications, right? So A1 instances provide that on-demand and easily accessible platform for ARM development. But really, you can run any workloads on these instances. Okay, so I think this came up during the fireside chat with Mohammed, right? Arm is working heavily on building partnerships with software vendors, right, to make sure that when developers are building applications for the Arm architecture, it's a seamless experience, right? So we have a list of OSVs and ISVs that's ever expanding. Obviously, since AWS announced Graviton processors and A1 instances, this list is rapidly growing. All of the major Linux distributions are supported. So we have Amazon machine images for A1 instances in all of the major distributions. In addition to that, we have support for Docker Desktop, right? So if you're using Docker Desktop for development, that has an option to build and compile Docker images for the ARM architecture, right? Which you can just deploy onto A1 instances. Other container support, if you're using the Amazon container service, those support A1 instances. And if you're using the Kubernetes service, how many of you are using Kubernetes? Okay, so a few. EKS support for A1 instances is in public preview. And additionally, all of the common tools that people use to monitor and manage EC2 instances are all supported. For example, Amazon CloudWatch, Systems Manager, and other services. So this is a quick spec sheet of the instances. They are available from all the way from medium to 4 extra large t-shirt sizes, ranging from a single vCPU to 16 vCPUs and 2 gigs of memory to 32 gigs of memory. We have also expanded into additional regions. When they GA'd last year, they were only available in North America, but since then we have expanded into Frankfurt, Mumbai, India, Sydney, and Tokyo regions recently. So if you have a global operation, these instances are available globally now. Okay, so that's it. And we do have, as Bhumik said, we do have the $50 credit card for AWS that we'll be handing out at the end of the session.
Yeah, thanks, Nilay. So quick overview of what we've done with NGINX Plus on the A1 instances. As you can see in the chart here, we basically took A1 and a few other instances, C5, M5, M5A, and went through performance testing to showcase the cost effectiveness of it, right? So we can say up to 40% by running A1 NGINX Plus as a reverse proxy and API gateway on A1 instances compared to your C5, for example. And we go through some, we'll go through the technical details of it. Julio will cover that exactly on what we tested. But that's what we've been working with NGINX and AWS last few months. We have a blog and a paper. We'll share the link so you can refer to that as well. The other thing I would like to highlight here is that the NGINX Plus AMIs or Amazon machine images are available in the marketplace. And they also have a free trial for you guys to try, right? So depending on how your environment looks like, if you have a test environment up there, you could try this out for a month. I think it's a month free trial. So it's really easy to use and to get started as well. So with that, I'm going to hand it over to you, Julio, to go through the details.
All right, thanks, Bhumik. All right, so I'm going to go over basically the testing methodology we went through to arrive at the 40% cost savings, and we'll go into some detail, show some more numbers and all that to get a good sense of this. So at the top level, high level, we basically did some throughput testing, right, on various EC2 instances running NGINX Plus, although you could do this with open source as well. The use cases we're looking at specifically were testing reverse proxy and API gateway cases. And so, and the whole point of this was, again, to determine the cost performance of this, right? Where do different instances stack up, basically. The metric we're using here is HTTPS requests per second, that's our throughput number we're looking at now. And I'll get into that in a minute, but I just want to point out that the white paper, which we'll have a link for, in there we have the NGINX config files, right? Exactly how we ran it, how we ran work 2, the benchmark tool, all that. So you can you can refer to that if you want to take a look. So anyway, this is the test setup, right? We have 3 instances basically per test iteration. On the left hand, we use the load generator, right? And this does HTTPS requests for static files in this case, right? And for what I'm talking about here, we're just looking at small payloads, and we simulated a small payload just basically by running 404 errors, which is like 300-ish bytes in this case. And then also just 1K file. We do have data for various sizes beyond this. We're showing it at the booth if you want to take a look, but really the story is kind of the same regardless of what size you use, so we found this is just sufficient for this context. The work generator is running work 2, right? So that's a HTTP/HTTPS benchmarking tool, and that's what's going to give us our metric, right? That requests per second. And and the last thing about the load generator is it's an M5 4x large, so relatively large just for the fact that we want it to be a big pipe. We don't want that to be in the critical path. That's not what we're measuring, right? So you want that to be big. Then moving on to the instance under test, that's what we care about, what's in the middle, right? This is running NGINX Plus, an instance, and it's configured for reverse proxy and API gateways. Now, with the same single instance as we use to test the reverse proxy path and the API path, right? It's really just what your URL you request, right? In one case, the reverse proxy, you just match load balance, right, forwarded along, and then we have other a different path would actually get matched and rewritten and then matched and then for load balanced, right? So, and again, this is that config that sets all that up is in the white paper. And yeah, we looked at a few different instances for this here. We have the A1, right? That's the Arm Graviton-based instance that we've been talking about. And then we looked at the C5, M5, M5A, as well as a few different sizes from large, which is 2 vCPUs, up to 4x large, which is 16 vCPU. And I mentioned, yeah, we are doing load balancing, but in this specific context, we do kind of a simulated load balance, meaning you have one upstream, it's listening at multiple ports, and we're just basically balancing across these ports, these different ports. Now, we did that for just to keep things simple. So we did, on the side, did a separate test where we had actual, more upstreams, and the results came back the same. They're within noise. So we figured it's okay to just do this sort of simulated port balancing for our testing. And again, so this is what we're measuring, the throughput. We want to see what is the maximum RPS this can sustain through our testing. And then the last thing is a upstream static file server, right? Serving all the different files we're requesting. Again, here we're just doing the small payload and the 1K. And similar to the load generator, it's a relatively large instance, right? We have the M5 4x large. Again, we don't want that to be a bottleneck, so that's why it's very large. And some numbers now. So a handful of things I want to point out. So first, we're just showing A1 and C5. We tested all these other instances as well, but just so that I don't have to throw too much data at you and kind of make people dizzy, I just picked out the one that was more competitive, which was the C5, compared, of all the others. So we're going to compare the C5 with the A1 since that was the most competitive within this testing we did. So we have the A1 on the left and the C5 on the right, and we also have each one broken out by its instance size, right? So from large on the left, which is 2 vCPUs, as I mentioned, and then up to 4x large. Now, the first thing I'll point out is if you look at any one of these by itself, either C5 or A1, you'll notice that as we go up in instance size, meaning more vCPUs, right, we kind of have this scaling, right, where your throughput goes up. And that's because at these smaller payloads, you're bounded by CPU, basically. So you add more vCPUs, you get more score, right? That's true for small payloads. If you go to the bigger side, that you start to get a little more network bound, so that scaling effect kind of diminishes, right? But that's why you see that incline there. The other thing is, if you look between A1 and C5, you could just look at it and say, well, for example, A1 large versus C5 large. C5 large here shows about twice as much throughput, right? Now that may be true, but you also have to realize there's a cost difference here too, right? So you really need to look at this as what am I paying for, right? Performance per dollar, right? So, and as we step through, you'll see where the A1 fits in this context. The other thing is I want to point to the A1 large, which is 16,089 RPS within this testing. And again, this is the 404 kind of small payload, right? A couple hundred bytes. But I want to point out the 16,089 because just kind of use that as an example, right? When we show the cost table and kind of how things play out with these numbers. So on the next slide, we did API gateway case, but with a 1K file. So things to notice here are basically you have that same shape, that same kind of vCPU scaling. That's not a surprise. It's a small file. The other thing you'll see is that across the board, the scores dropped a bit, right? So that's because, again, we're CPU bound, and now we're adding more processing because we have to match URLs and rewrite the URI and then forward, right? There's a little more processing you're asking it to do, so scores are going to drop a little bit. But this is true across all instances we tested, all sizes, all that. That's just what the case is going to be here. Moving on, yeah. So with those numbers, then we figured, okay, so let's take a look at this from a cost, right? What does it cost? So what performance you get versus what you're paying for these two cases, the reverse proxy and API. So the deployment scenario we picked out was basically run 3 of these instances at 66% utilization. This way, you can kind of have some fault tolerance if something fails, right? You can still meet the throughput you're looking for. And so when I say 66% utilization, I'm really just saying 66% of that maximum throughput value that we get. Because depending on what you're doing, you're bounded in different parts, right? So we're just looking at the final metric we're looking at, 66% of that. All right, so with that scenario, then we look at, okay, so what is it going to cost us to run these 3 instances at various levels of throughput that might be required for a specific case. And we looked at a range from 1,000 RPS up to 200,000, right? Like where do you fall? Where does the cost fall in between that range? So here's the first look at that table. And so let me explain a little bit. On the left-hand side, you see the first column, total RPS. That's basically your required throughput, right? What are you looking for? What do you think you're gonna need? And again, these are the numbers for the reverse proxy small payload test. So then the next column over, RPS per instance, that's basically what you would expect each individual instance to be able to sustain for that requirement, right? Since we're running 3 instances, let's look at that first row, 1,000 divided by 3 is 333, right? So you would expect each individual instance to be able to handle at least 333 RPS for this test, right? That's what we're going for. Then the columns beyond that are the different instances shown against each other with, kind of going down with as you increase your throughput requirements, right? And what the cost is going to be. So I mentioned earlier we had the A1 large was 16,089 RPS. That's what we had measured with this specific test. So, and we got to take 66% of that, right? So in reality, our effective throughput that we're willing to absorb per instance, let's say, is 10,618. So basically, what you need to do is go down the second column and find, where are you under 10,000, basically, right? So we get down to 25,000 RPS, which each instance is 8,033, which is under that 10,000, rough 10,000 number. So right at that level, we're saying that the A1 large can sustain for small file size payload can get us up to 25,000 RPS, right? And so when we talk about this 40% savings, this is where we see it. If you look at the next instance over, C5, right, this 25 cents and a half per hour. You look at the A1, 15 and a third per hour, right? That's a 40% discount there. That's where we're talking about the 40% comes from. And then here is the same table for the API gateway case with 1 kilobyte. I'm not going to step through an example because the story is pretty much the same. It's the same thing, same result, basically up to 25,000 RPS, throughput required. The A1 will be the most cost effective with the same sort of 40% over the next instance that you can measure, right? So, the key thing here is that for these kind of moderate workloads, they'll work, the A1 will work, and hopefully this encourages you to take a look at it, right? You might have places in your deployments where, this lower throughput may be acceptable, right? You might not necessarily need the full throughput from C5, for example, right? And so there are cases, maybe in your backend, QA, wherever, right? There could be cases this could work for you, right? So we just want to encourage you to, if you haven't looked at A1, you should probably take a look at it, basically. And I believe that is all. Sure. Yeah. Thanks.
Thanks, Julio. We'll have some time for Q&A. But basically, as you saw the example we had with 3 instances at 66% util, one of the key takeaways is that it's going to scale out, right? So using the performance throughput testing we've done, you could easily scale it out to n number of instances, and the value prop will stay true. So what we've worked with NGINX on is that's how most deployments are in AWS, is how you scale out. And when you need larger RPS values, you're usually, there's some other design decisions as well there, right? Meaning it's not just per instance size that you're looking at. You might have different regions within AWS that you might scale and do those design decisions accordingly. So yeah, I think before we do a Q&A, those are the links for the blog and the white paper. If you go to nginx.com blogs, it's on nginx.com, and the white paper there as well. But yeah, as we said, there are free trials available. We'll give out some credits here. We appreciate you hanging out here in our session. We'll just open it up for Q&A. Thanks a lot for your time. Any questions? Yeah.
You might cover this in the blog post. Right, yeah. But what about computationally heavy workloads on the proxy side? So things like super large RSA certs, regex for URI processing. How do you kind of foresee that impacting an A1 versus others?
Have you done any work in that? Do you want to answer that?
Yeah, so overall, we've not tested anything like that yet. This is sort of a first order look at it, right? Just to see how does this stack up. So yeah, you're right. That's just something we need to look at. It is on the cards to look deeper, right? And so that's another aspect we're looking at. So yeah.
Any other questions? Here's my. You got the cards, right? All right. Thanks a lot, everyone. Take care.